Hello everyone. This is Uzair Shah from Hamad bin Khalifa University College of Science and Engineering. I would like to thank all the co-authors to make this happen. So today I'm going to present our paper entitled Vaccine Rollout and Sentiment Shift in Twitter Population, a Surveillance Study. So agenda for today's presentation: introductions, research objectives. I will explain briefly the methodology, explain and elaborate the result, discussions, limitation, and finally I will end my presentation with the conclusion. So introduction. People sharing thoughts and opinion through social media like Facebook, Twitter. But Twitter is a most popular social media platform that's people sharing thoughts, sentiments, and opinions and reacting with other people's. So Twitter is also a great source of information to investigate people's interaction and sentiments. Public perception, opinion, sentiment in order to combat COVID-19 pandemic can be identified through Twitter data analysis. But Twitter data analysis, it's challenging. Like Twitter data is unstructured, short in length, doesn't follow grammatical rules. People use slogan words, slogan praise, which make it more complicated to interpret and get insight from the data. People also use emoticons. It's human facial expression, which it make more difficult to interpret it in a correct form and get information and get insight from the data. So problem statement: can we understand and identify public emotion on vaccine rollout throughout the world? Can we observe any change or any shift in the public sentiment upon vaccine rollout worldwide? So the main objective of this paper is to find the variation or shift of sentiment of Twitter user before and after vaccine rollout. So methodology, I will explain briefly the methodology we adopted to conduct this study. So first I will explain the study data, then pre-processing, how we find the sentiment analysis, how we compute of user sentiments, how we find the shift in sentiments, and also we perform a thematic analysis. Now study data. So we for the study this paper we utilize a publicly available data sets. The author of this paper and this data set, they are continuously downloading the COVID-19 related tweets since March 2020, and after each week he updates his GitHub repo with new tweets. We filtered only September 2020 and March 2021 data, and T1 here T1 is representing a time frame before vaccine rollout, and T2 present a time frame after a vaccine rollout. So we used a Twak Python library to download the full text from the tweets IDs. Further, after downloading all the tweets, we removed and we identified the verified users from the metadata of the tweets. Why we removed? Because verified users are those who are from the government organizations and celebrities and other organization of the governments, and his sentiment are consistent. So that's why we removed the verified user tweets. Further, we also removed the irrelevant tweets that are not related to the studies. We also normalized the Twitter text and also removed the stop words, punctuation marks, and replaced the links, user mention, and hashtag by empty string. These four steps is for to find the sentiment, and the last step we perform for only thematic analysis, and we find the lemma words of the tweets, of the words in the tweets. Because in topic modeling it show same meaning, like if we use go, went, gone, so we convert the went and gone with a lemma word go. So we use in order to find the sentiment of the text, we use a Sinti-strength Alexan-based sentiment analysis Python library. So in this library, that the text was represented by a bag of words and a predefined dictionary. The value is defined and the value is replaced by a numerical value, and then finally the Sinti-strength combine the value and find the sentiment. So in strength library, they report the two sentiments, positive and negative. They also give the positive. For example, if like I say, I love traveling, but I hate hot weather. So in this sentence, in this para, it's containing two meaning, like also positives and negatives. So that's why they are reporting both value. So in this paper, we categorize into positive, negative, and neutral. Like we just give only one value. If the positive value is greater than the negative, so we consider is a positive, and if it is less than a negative, so we consider it is a neutral. And if both the score positive and negative are the same, so we consider it as a neutral. Computation of user sentiments. So first we consider only those users whose more than one tweets in each time frames, and remove all other users. And to calculate the overall sentiment of a user in both T1 and T2, we calculate the overall sentiments and decide the overall sentiments of a user at time period T1 and T2 based on the majority of votes. If the like a person has more than 2 or 3 tweets, so we consider if the majority of votes. If it is more positive tweets, so we consider it as a positive, and if it is not, negative, and so on. If there is a tie between positive and others, so we consider positive, and in case of neutral and negative, so we consider it as a negative. Now computing the change of or the shift in sentiment, so we categorize the user into two groups, G1 and G2. G1 representing those users whose sentiments were positively shift, like from negative to positive, their sentiment were negative in the T1 and moving positive to in T2. So this is a positive shift, like, and also negative to neutral and neutral to positive. So we consider those users as a positively shift users. And G2 representing a user whose sentiments were negatively shift, like their sentiment were positive in the first time frames, and now after the vaccine rollout their sentiment is negative, so we consider this is a negatively shift users. Further, we conduct a thematic analysis. For the purpose, we apply a topic modelings on each group in both time periods. So we use LDA algorithms to perform a topic modeling and produce a unigram and bigrams worlds. So it's LDA required a free defined number of topics. So we, through discussion and concession, we came with 15 topics. And further, we manually analyze the topic represented by a unigram and bigram word produced through LDA. And we after it we manually analyze and extract the themes. And we also highlighted 20 random tweets for each theme under a supplementary file. There is a GitHub repo. We uploaded all data. Now moving to the result section, I will elaborate the data, the tweets collection, sentiment, the result of the sentiment analysis, shift of user sentiments between T1 and T2, and also the themes, thematic. So data collection, so as I mentioned before that we downloaded the September data and March 2021 data. So we represent it at T1 and T2. T1 is the September data before vaccine rollout, and T2 representing the March data after vaccine rollouts. So we downloaded 7.3 million tweets of in the time T1 and 4.8 million tweets in T2. And after removing the verified users, we like non-verified user tweets at T1 is 6.6 million, and in T2 it's 4.2 million. And further, after removing the irrelevant tweets, finally we end up with 4.7 million unique tweets in the T1 and 2.99 million in T2. So sentiment analysis at T1 and T2. So in the time frame 1 before vaccine rollouts, around 17% user sentiments were positive, and 38.3% were neutral, and a very big number of 44.7% people were negative. Their sentiments were negatives. But after vaccine rollouts, we notice a very small, slight improvement. Their sentiment is positively shift, and like 18% was positive, and 42% were neutral. Their sentiments were neutral, and around 40% their sentiments were negative. So a slight improvement, like 44%, and now moving to 40%. Now we find the sentiments, shift of the user sentiments. So as I mentioned before, that we find the overall sentiments of a user, like if there is many tweets of the same user, so we combine it using on the majority votes. If it is positive, so we consider it as a positive. So around 3.5% users, their sentiments were shifted from negative to positive, and at 19.8% the users' sentiments were shifted from negative to neutral, and also 3.7% from neutral to positive. And also it's the same for the negative shift, 14.3% from neutral to negative, to 2.5% from positive to negative, and around 3.5% from positive to neutral, and more than half of the users, their sentiments were the same, inconsistent in both time periods. So after we also conduct a thematic analysis on each group at both time frames. So in the group 1 user at before vaccine rollouts, their tweets were more concerned about their tweets are worried and fears, and also concerned about the mental health and economic losses. On other sides, group 2 user at time period 1, they were more hopeful. Their tweets were concerns about the vaccine rollouts, the precautionary measurements, funding for the vaccines, and so on. And in time period 2, the group 1 users, after when vaccine is rolled out, the user were more concerned about vaccine safety and efficacy, release of lockdowns, travels. On another side, the group 2 users after vaccine rollouts, they are more concerned about the side effect of vaccine, rapid development of vaccine, and new coronavirus variants. So about 27% of users G1 sentiments change positively, and 20% of G2 user sentiments change toward negative. So after vaccine rollout, most users from G1 than G2 were more optimistic about to fight against the COVID-19. And G1 users shifted positively as they were more optimistic about the vaccine safety and efficacy, and on other sides, negative shifts as they were more concerned about the side effect of vaccine and the phase of vaccine development rollout. And over half of the user, around 25% user, overall sentiments will remain the same in both periods. There are several limitations contribute to these studies. We only analyze the English tweets that are not generalize our findings to all languages. We collected the data for like 2 months only, month before and after the vaccine rollouts, so our finding may not generalize the for long period. We also scrape the user whose sentiment whose tweets are less than 2, so it's not generalized for all user. And we also consider the Twitter data, which our finding is not generalized for all the social media platform. So conclusion. So over half of the Twitter user were indifferent when we compared their tweets in two time frames before and after vaccine rollouts. So it's indifferent. their sentiments were shifts. And this study will help the policy maker and health profession in understanding the public perception and sentiments toward the specific event like vaccine rollout. And this study will also help to explore and identify the factor affecting the variation in their sentiments when something happen in some new event is occur. Thank you so much for watching the video. If anyone have the question, so please contact me through my email. Thank you.